right, so pre-calculus section 6.2, law of cosines, day one. Just gonna do a couple examples of law of cosines here. We got law of cosines written. We already talked about it a little bit in class. We're not gonna go over the proof or anything like that, but basically, law of cosines is an extension of the Pythagorean theorem to, oh my goodness, I just found an error. An extension of the Pythagorean theorem to a non-right triangle. When I wrote this up, I started with A up here. Don't worry about it. But basically what the law of cosines is telling us is, well, it's a relationship between four pieces of information, three sides and one angle. So the thing to remember here is that the side that's all by itself, it's like the c squared, b squared, or a squared on the left side of the equal sign, is always opposite the angle. So these two letters are going to be the same, like side C, angle C, side B, angle B, side A, angle A. And then the other two sides are here. So like it's side C, side A, side B, AB. Side B, AC, AC. Side A, BC, BC. Okay. So let's go ahead, we're going to do example one where we have one angle and two sides, and we're going to solve this triangle. Both these examples, we're going to solve the triangle. So we've got angle A is 80 degrees, so almost straight up and down. So A equals 80 degrees. B equals, let's make this B 16 meters. C equals 12 meters. All right. So something like that. I don't know what it's going to look like. We'll find out. So this is going to be side A over here. This is angle C. This is angle B. Now to solve the triangle, first we're going to find side A. We're going to find side A by using the law of cosines because we have the two other sides and we have the angle opposite side A. So we're going to set this up, our law of cosines, we're going to set it up as a squared, our unknown, equals b squared plus c squared minus 2bc cosine A. So I'm going to say a squared, we don't know what side length A is, equals b squared, so 16 squared, plus 12 squared, minus 2 times 16 times 12 times the cosine of angle A, which is 80. All right, now I'm just going to go through. A squared is going to equal each of these. And I'm just going to go, well, 16 squared plus 12 squared, that's 400. Ooh, 400. So 16 squared is 144. Oh my goodness, it's not 144. Sorry, it's 256. 256, this one is 144. So together that gives us, wow, just write down all the wrong numbers. Together that gives us 400 minus 384 cosine of 80. And then, I mean, really we could just plug this whole thing in our calculator. I don't know why I'm doing it step by step. But make sure here you go 400 minus 384 times cosine of 80, not 400 minus 384 and then multiply. So just put all of this in your calculator. Make sure you're in degree mode, and we get a squared equals about 333.319. That's what a squared is equal to. We want what a is equal to. So we're going to have to square root both sides of this equation. So we're going to square root and square root. Square root. Square root. And that gives us a is approximately 18.26. 18.26 meters. So A is about 18.26 meters. All right. So we have now all three sides. And the goal here is to solve the triangle, so that means I need to find the remaining angles. Now, luckily for this problem, we already found the biggest angle. The biggest angle is given to us, it's 80, right? And that's opposite our largest side. We know that's the biggest angle because side A is the biggest side, and the biggest side is always opposite the largest angle. So if this were not the largest side, we would want to find the smaller of the two remaining angles, because we're going to use law of sines, and law of sines is going to give us an angle between 0 and 90. Because this is our largest side, and right, we already have this angle, we don't need to worry about which one we're going to do next. But just to keep it consistent, I'm going to find angle C next, because it's just kind of an easy thing to remember when you're using sine or law of sines to find the smaller angle first. So I'm going to solve for angle C, and I'm going to set up my law of sines. I'm going to say sine of C divided by C. C is 12, so I can just write 12 there. Equals sine of 80, which is angle A, divided by side A, which I'm just going to use the 18.26. It's not exact, but it's close enough. All right, to solve this, I'm going to multiply by 12 on each side. To undo that 12, I get sine of C equals 12 sine of 80 divided by 18.26. I got to undo the sine, right? It's sine of C, the function, sine, evaluated at C. I need to undo that sine, so I'm going to use the inverse function of sine, sine inverse. I'm going to apply that to both sides. I am not multiplying by sine inverse. I'm applying the inverse sine function to each side of this equation. And that's going to give me C equals, approximately, this really should be a squiggle equal. And I'm just going to plug this into my calculator here. So, sine inverse of 12 sine, oh, hit the wrong button. Sine inverse of 12 sine 80 divided by 18.26. We get 40.33 degrees. So C is about 40.33 degrees. So 40.33 degrees for C. And lastly, I want to find angle B. To find angle B, I'm just going to go, well, these three need to add up to 180. So angle B is going to be 180 minus the other two angles. Minus 80 minus 40.33, which is going to be what? 59.67? I'm going to double check that. If I can plug this in properly. Yeah, 59.67. So it's about 59.67 degrees. We can double check that our answer makes sense. The smallest side, which is 12, is opposite the smallest angle. The largest side is opposite the largest angle. The medium side is opposite the medium angle. That all makes sense. Cool, we got it. All right, let's do another one. We're gonna do example 2 now. So example 2, we're given 3 sides, and we're asked to solve the triangle, which means we gotta find all the angles of that triangle. All right, so we've got side A equals 6, side B equals 8, side C equals 12. So I just like to put the longest side on the bottom. So 12 is side C. So A and B. So B equals 8. A equals 6, C equals 12. So we have side B here, or sorry, angle B, angle A, angle C. Woo. Okie dokie. So, to avoid worrying about, sorry, let me rephrase that. Eventually, so we're going to use law of cosines to find one angle. Then we can use law of sines to find another angle. when we're using the law of sines to find an angle, we got to use the inverse sign. And the inverse sign is going to give us a value between 0 and 90. To avoid that, like, is this angle the one that inverse sign gave us, or is it 180 minus that? What we can do is we can just find the value or the measure of the largest angle using law of cosines, because the inverse cosine, which we're going to have to use in order to find what the angle is, the inverse cosine function has a range from 0 to 180. So it's going to give us the right angle. Well, not like right angle, like 90 degrees. It'll give us the correct angle. Whereas if we use law of sines on an angle that's larger than 90 degrees, we'll get 180 minus that, just because of the way that the inverse sine function works. Okay. And we can talk more about that another time if you want to go over why we're doing this. But what I'm going to do is I'm going to try to find angle C first. So I'm going to use this version. I want angle C, so I'm going to use C out here, C squared, which is going to be 144, 12 squared, and then equals A squared plus B squared, blah, 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 cosine C. So I'm going to write that up. So I have a 12 squared equals A squared plus B squared minus 2AB, and then cosine of C. And I'm going to go through, simplify, and solve for C. So I have 144 equals 36 plus 64, 100 minus, I don't know what 16 times 6 is, sorry, 96, I should have known that. Oh, 12 times 8 is 96. Yikes. Should have known that. So 144 equals 100 minus 96 cosine C. The 100 came from adding the 36 and the 64, 6 squared and 8 squared. The 96 came from 9 times 2 times 8. Now, one thing that I often see pre-calc students do is they'll just smush this together and say like 4 cosine C. Cannot do that. No, 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 no. We cannot do that because this is the number 100. This is not the number 96. This is the number 96 multiplied by some unknown value. Because we don't know what angle C is yet, we don't know what 96 cosine C is. So we cannot combine these, we gotta keep working backwards. So, what I'm gonna do is I'm gonna get rid of this 100, minus 100. That gives me 44 equals negative 96 cosine C. Divide by negative 96. Right, and that can give us, I mean, we can simplify that to what, like 11 over 24. I'm just gonna double check that. 44 over 96. Yeah, we can keep it as negative 44 over 96, so that's fine. So we have negative 44 over 96 equals cosine of C. I want to get what C is equal to. So what I'm going to do is I'm going to take the inverse cosine of both sides. So I'm going to go inverse cosine, or arc cosine, of each side, and that's going to give me angle C is approximately, and I'm just going to plop that in my calculator. So inverse cosine of negative 44 divided by 96, 117.28 degrees. 117.28 degrees. So angle C here is 117.28 degrees. All right. So the thing to remember is when you're solving for an angle, when you choose the largest angle to solve for, because cosine's going to give you that every time, or a lot of cosines will give that to you. You don't have to worry about like 180 minus or any of that stuff. You pick the largest angle, and then you set it up so that the side opposite the angle you're finding is over here in the law of cosines. So if we were solving for angle B, we'd have put the 8 on the outside and the 12 would have replaced the 8. And we would have used this one if we wanted angle B. We wanted angle C though. All right, so now we can find either of the two remaining angles. Both of these angles have to be under 90 degrees because That's more than 90 degrees, and they all have to add up to 180. And we can't have negative angles. Sorry. So, let's go ahead and just like, I don't know, let's find angle A. Why not? So I'm going to go sine of A divided by side A. So sine of A divided by side A equals sine of 117.28 divided by 12. So I'm using my law of sines here. Multiply by 6 on both sides to undo that 6. Oh, I can't cross that out. I mean, I could make it 1/2 because 6 over 12 is 1/2, but regardless. So now I have sine of A equals, I can go 6 over 12 to get a 1/2. I'm just going to leave it like this though, that's fine. All right, it's 1/2. 1/2 sine 117.28. And then I'm just going to take the inverse sine of each side to undo the sine function on A. And then in my calculator, I'm going to type this in. I'm going to go A equals, I'm not going to do A equals, but I'm going to type this in. Sine inverse of 6 sine 117.28 divided by 12. So, sine inverse 6 sine 117.28 divided by 12. Enter, boom. And we get about 26.38 degrees. Okay, the last thing I want to do is find angle B. So I've got 26.38 degrees. To find angle B, well, I've got the other two angles. So it's just going to be 180 minus 26.38 minus 117.28. Right, it's going to be approximately that. Because these are both rounded numbers, it won't be exactly the right number for B, but it's close enough. So 180 minus 26.38 minus 117.28 gives us about 36.34 degrees. And there we go. We have solved the triangle. So, hopefully these couple examples were enough to help you work through the homework. The homework's basically just a bunch of problems like this. If you have questions, drop in for office hours. Let me know. Thanks for watching. Hope you enjoyed it.